Back Mustangs to another edition of sorry, I got a dog here that just like came in right as I was starting the video. Another edition of No Here No Problem. We are going to be doing chapter 9 section 3, which is dealing with all things hyperbolas, and this will be the last section, excuse me, of chapter 9 that we're going to be dealing with there, okay? So hyperbolas is just another type of conic section. Now, how do we get a hyperbola? Let me show you a quick graphic that kind of goes through how we get all the different ones that we've had so far. You know, if you look at this one that we have right here, let me go ahead and zoom out here. So that I'm out of the way, as usual. So the first one that we deal with here when we're looking at these is a circle, which is when we make a section straight across our conic. When we do a diagonal one, it gets elongated, and this is where we get an ellipse. When we go straight across it and out of it, and we don't get the full circle portion of it, this is when we have a parabola. And if we take the cone and do a reflection and we go straight up and down on it, this is where we get a hyperbola, which is where the parabola is another parabola. So there's a reflection there. And with a hyperbola, it's pretty cool. We just like with all the other shapes, we have a property that takes place related to the focus, which let me show you this right here. Which anytime we have a beam of light or anything like that leaving one of my focus, it's going to bounce and reflect off of my hyperbola and go over to the other focal point. Okay. Let me show that one more time here. Okay, you can see that this is going to, every single point that leaves is going to bounce and reflect. And what you should notice here is that the angles that take place right here and right here, the angle of incidence and the angle of reflection is exactly the same throughout the entire picture. And every single time it's going to bounce back and hit this other focal point on the other side, which to me is, I think, pretty cool. So let's jump into all the properties, though, of hyperbolas. So we've got to get used to drawing some of the stuff that's in here. You'll see right here when we're looking at these problems, these two lines that are right here, they're dotted lines. Those are called asymptotes. We're going to draw those, but they're not part of the actual overall picture of a hyperbola. The hyperbola itself is these two curves that follow my asymptotes. They just never actually cross them. Same thing with this one where it opens in the vertical direction. They follow those asymptotes. They just never actually touch them. In order to generate this, we're going to generate this fake box that's right here, which we'll talk about in a minute, and all the parts that go into it to actually create it. So in this case, this is the radius in an x direction, and this is the radius in a y direction. And instead of us creating like this circle that's inside the middle of it, what we're going to do is we're going to actually take the points that get generated from my vertices and my co-vertices, and we're going to generate these corner points instead, where the points actually meet up. That will then generate this box for us, and then you can see the diagonals of our asymptotes go straight through this and into the center of it. Okay, so we're going to talk about how to generate all that stuff here in a few minutes. The formulas, you'll notice, are exactly the same as when we did ellipses. It's just that the difference here is that we have this minus in the middle. And you'll notice for both of them, the minus is always going to sit directly in the middle. And what that minus does is, if you think about an ellipse, imagine taking an ellipse and breaking it and then turning it out, you get this hyperbola. Or if I took it and I broke it and I turned it down, we get this hyperbola. Well, remember, negatives cause a reflection to take place in our pictures, okay? The other important thing to notice is this. That a squared value in a ellipse didn't matter where it was. A squared could have been underneath the x or it could have been underneath the y. The difference in these is that when we're talking about hyperbola, this one right here determines everything for us, okay? And the first one over here determines everything. What I mean by that is when we have x being squared, that tells us it's going to open in the x direction. When we have y being squared, it tells us it's going to open in the y direction. So the y direction is up and down, the x direction is left and right, okay? The center is still always going to be the center. You just have to be mindful of the letters that we're dealing with. H and K and H are switched in the other one. The vertices, now this is important. This is where a lot of people make mistakes. Vertices are going to have to be on our actual hyperbola. That means that these 2 points at the top and the bottom, those are not my vertices. And it doesn't matter long or short. In an ellipse, the vertices were always the longer ones. In a hyperbola, the difference is that those 2 values are going to be on my actual hyperbola. So these are going to be always the points of the vertices will be always on my hyperbola, not in these other parts here. Just like here, my vertex is going to be on the top and the bottom there. One of the common mistakes that people make is when they're drawing their graphs, they draw directly through those imaginary lines that were there, and they make a graph that looks something like this. We're going to avoid that. We're going to make sure that we draw our entire box, and we go through the vertices, not to the center. Okay? The focus for this is on the inside of my curves. Just like in a parabola, the focus is on the inside of the curve itself. We don't want to have the focus be over here. We want the focus to be on the inside of my actual curves. Okay? Same thing with the top and the bottom. So the formula to do that is going to be, actually, you'll like this one. It is the Pythagorean theorem. It is actually a squared plus b squared is equal to c squared. And we'll talk about how to apply that. But remember, that value, that focus value, is always going to be coming off of the center itself. So we need to establish the center. The last thing to create here is the equation of the asymptotes. Now this is, you'll notice, or hopefully you notice, this right here is the equation that we're talking about point slope. In order to create any equation of a line, you need a point, you need a slope. I'm going to show you how to get all that information very quickly. But what I want you to notice most importantly here is that the y minus k and the x minus h, those are already found for us. Those are part of my center. You got x minus h and y minus k. You're just going to pull those into your point slope formula. And then the a and the b values are going to come from these two values here, which I'll show you quickly how to find in the graph itself too. Okay? So let's jump into these. Again, just like previously, it's just do the problems and you'll see how quickly everything just kind of jumps out at you. All right? So starting here first, let's start with these. The x minus 3 and the y plus 1, which is supposed to have a 2 on it. There's all kinds of typos on this. I apologize. The center for that is going to be at 3, negative 1. So let's go ahead and put a point at 3, negative 1 on here. The radius in the x direction, when you look at this, is, oh, by the way, real quick, this is right here, since it's x minus 3 being squared. We know that the graph is going to open in the x direction, so it's going to open left and right. All right? So the a value here is going to be 25, I'm sorry, the square root of 25, which is just going to equal to 5. And the square root of 4 in the y direction is going to equal a 2. So this tells us that in the x direction, we're going to go 1, 2, 3, 4, 5. Okay, and we're going to make a point right there. And then we're going to go 1, 2, 3, 4, 5, and we'll make a point right there. This point right here and this point right here are my vertices, because that's what comes in that first spot there. This is the one that generates our vertices. Okay. Now we're going to go ahead and move 2 in the y direction. So we're going to go 1, 2, and make a point. All right. And then we will go 1, 2 in the other direction, 1, 2, and make a point right there. So now we've got all the points that we need in order to actually create the box and do all the other stuff that we need to do. So before I look at anything else in the picture, let's go ahead and do all this. You ready? We're going to take our points that are generated right here and here, and we're going to bring those together to get the corners of my box. So we're going to put a point right here on the corner of my box. We're going to go ahead and take this point and bring them together to make the box. And we'll do the same all the way around. Okay? From here, we're going to go ahead and generate a box itself that, in this case, what I'm going to do is I'm going to go ahead and make it a dotted line so that we can see that it's not really there. It's just like an asymptote for our graph to follow. We're going to go ahead and make diagonal lines that go through the corners of this. Those are going to be our asymptotes that my graph is going to follow. Okay. I'm going to highlight both of those, and we'll make those dotted as well. Okay. And then again, my graph is going to open in the x direction. So what's that going to look like? Well, starting from my vertex, we're going to go along my asymptotes here and make a curve. And then starting from my vertex, we're going to go along and make my curves. You just made the entire graph just from those couple pieces of information. Okay. So where are my vertices? My vertices, we said, were the 2 points that were over here where we labeled them V. So we got one at negative 2, negative 1, and then we've got one over at 8, negative 1. Okay. When we look at the co-vertices, those are the points that are on the top and the bottom that were right here and here, and that was 3 at 3, 1, and 3, negative 2. 3, 1, and 3, negative 2. My focus for this, if you recall, is a squared plus b squared is equal to c squared. So we take our values that we have, the a's and the b's, and it's going to be 25 plus 4 is going to equal c squared. So we have 25 29 equals c squared. So that tells you that their c value is going to be equal to the square root of 29. So just like we did previously with the ellipses, we're saying that the focus is going to be somewhere over here, which means we have to go in the x direction, okay? So that means taking your center here, which is at 3 and -1, we're going to move in the x direction, which means that we're going to go plus or minus root 29, and you still have that -1 there. Okay, so you're going to have 3 plus root 29 and 3 minus root 29, and then -1. The equations for your asymptotes, again, are going to just be extrapolated from the parabola itself. So we're going to have y plus 1 equals, and we're going to have x minus 3, okay? Those are directly taken from your parabola. I'm sorry, parabola. I said a parabola. It's a hyperbola. From your hyperbola. And then the other portion is going to be plus or minus. And again, so you don't have to overthink this. Slope is really easy to get from this picture. You ready? If I look at the point right here, that's the point that we just used, which is our center. To get to the next point over here, you do your rise over your run. And you can see here, I rise 2 and I run 5. Okay? So that means we're going to go plus or minus 2 over 5. There you go. That is your asymptote. That is the equations. That's all of it put together. Ready to try some more? Now with this one is going to be a little different because the y squared comes first. That tells us it's going to open in the y direction. So the a value here is going to equal square root of 7 because the a value always comes first. The b value is going to equal 3 because it's the square root of 9. My center for this is going to be at -2, 4. So we'll go -2 and +4. And we're going to go root 7, which is, again, between 4 and 9. As far as square roots go, like if we were to do square root of 4 and square root of 9, we know the square root of 7 will be somewhere in between. And so this is 3, this is 2. So if I had said square root of 7, we're going to be shifted a little more towards a 3 there, okay? So from my center, we're going to go in the y direction approximately 3. Ready? So we'll go 1, 2, and then a little bit more, and then 1, 2, and a little bit more. Those 2 points that we just made are my vertices. So let's do those really quickly. You ready? We are going to start from -2 and 4. That's my center. And we're going to go ahead and go plus root 7. And we're going to go minus root 7 to get to those. So the actual vertices are going to be at -2, 4 plus or minus root 7. Okay, that's going in the y direction. For my x direction, we're going to go 3 to the right and 3 to the left. So 1, 2, 3. 1, 2, 3. We're going to go ahead and make our points on the corners. Okay. Oops, those are terrible points, but you get the idea. All right, we're going to go ahead and make our dotted line border for this. Okay, if I can get that to work there. There we go. Let's go ahead and highlight that. We'll make it a dotted line. Okay, let's go ahead and do our asymptotes, which are going to go straight diagonally through this. All right, we'll go ahead and highlight those and make those dotted as well. You don't have to do this always, but I'm just showing you just so you can see that they're not really there. They're just asymptotes from a graph to follow. My graph is going to go ahead and move in the y direction. So we're going to make our points going this way. You can see in this one right here, I kind of went a little bit beyond it. Same thing with this one right here. Sorry, I'm not perfect. All right, and then the curve is going to continue going this way from my vertices, okay? I just did a poor job with the box, but the idea of the graph itself is there, okay? For my co-vertices for this, we are going to start from my center, which was at -2, 4, and we went to the right 3, which will put me at 1, 4, and we went to the left 3, which will put me at -5, 4. For my focus, we got a squared plus b squared equals c squared. So we've got 7 plus 9 equals c squared, which is 16, which means we're going to go 4. So from my center, we're going to go 4 up and 4 down. So from -2, 4, we're going to go 4 up from here, which will put me at -2, 8, and 4 down from there, which will put me at -2, 0. Okay, so those are going to be my vertices. I'm sorry, my focus. And I just totally put those in the wrong spot. Okay. And the last thing here that we're going to do is our asymptotes. Okay, so let's go ahead and pull that information straight out from the equation. We got y minus 4 from our equation, and we've got x plus 2 from our equation up here. And then we got plus or minus the b over the a. So we're going to go up, b over a, which is going to be 3 over root 7. Nope, that's not right. Sorry. Give me a sec. Just made a little mistake there. Sorry. So what we're doing is to get, again, from one point to the next, we're going to go up. We said root 7, and then we're going to go right 3. So it's going to be root 7 over 3. So it's going to be root 7 over 3. Okay? That's it on that one. Next one, same idea, same exact ideas, but what we're going to be doing on this is we're going to go ahead and get the equations. So same exact format that we did when we were talking about ellipses is let's take the x's and put them together. So when we put the x's together, we have 4x squared plus 4x. We want to take that leading coefficient out just like we did with ellipses. And so we take the 4 out and we have x squared plus 10x. We're going to complete the square, which means we're going to take the 10, cut it in half, which is 5, and square that. We're going to get 25. And then you think about what did we actually add to the problem? We actually added a 4 times 25, which means we actually added 100 to the left side. If we do the same thing with the y's, now you'll notice I put the negative portion second. Okay, that's because in hyperbolas, the minus portion is always the second part. Whatever we have here, we take this negative 9 that's right here, and we're going to go ahead and factor that out. Okay, so if I factor that out, we're going to be left with a negative 9, y squared minus 2y. Okay, that's just factor out negative 9. We're going to complete the square, which is half of 2. We'll give you that 1, and then squared is just 1. I actually put into this problem not a positive 9. Remember, we are taking and multiplying this value here by the 1 that's right here, which means that we have negative 9 times 1, or negative 9. So to keep our problem balanced, we start with a negative 55. Still have that. Excuse me. We're going to balance it by adding 100 to the right and taking away a 9. We simplify and write it in this binomial squared form, which is 4 times the quantity x plus 5 squared. And then we have the negative 9, y minus 1 squared, and all that is going to equal to 36. All of this equals 36 right here. So just like with the ellipses, to get rid of the 36 that's there, no matter what the number is, you divide it by that exact number. So if I did everything by 36, these fractions here, the 4 over 36, the negative 9 over 36, and the 36 over 36 are all going to cancel each other out. I'm sorry, not cancel, but they're going to reduce. So that's going to leave me with x plus 5 squared over 9 minus y minus 1 squared over 4 equals 1. All right, you ready? Let's do our graph. The center is at negative 5, 1. Left 5, up 1. Okay. My radius in the x direction is going to equal 3. So I go 1, 2, 3. And I go 1, 2, 3. Those are going to be my vertices because that is what comes first in my equation. So we'll put those values in there at negative 2, 1. And then we'll go to negative 8, 1 for my vertices. The radius in the x direction is 3. The radius in the y direction is 2. Okay, just square root of 9 and square root of 4. So let's go 2 in the y direction. 1, 2, and 1, 2. And let's do that all the way around so we can make our box. We're going to go ahead and complete the box now here. Okay. Let's change that to dotted. Let's go ahead and put in our diagonal lines. And let's go ahead and put in the diagonal line here. Okay. And then let's go ahead and change them so that they are dotted. And since the x comes first, it's going to open in the x direction. So we're going to go from my vertex and go this way. And we're going to go from the vertex over here. And there is your graph. So my co-vertices in this, which we already have, we're going to be at negative 5, 3, and negative 5, 1. Nope, not 1, negative 1, sorry. And then for my focus, we're going to go a squared plus b squared equals c squared. So we've got, in this case, we're going to have 9 plus 4 equals c squared. So c is going to equal the square root of 13. So from my center, going in the x directions, we're going to go ahead and use -5 plus or minus that root 13. That's going in the x direction. And then 1. So we're still using the same center, but we're going left and right from the center. The equation of the asymptote, we're going to pluck it straight from our equation. So we got y minus 1 for the first part. We've got equals. And then we've got, for the second part, the x plus 5. And then we're going to say plus or minus. Look at your picture. You can see that you're going to go up 2 and then to the right 3. 2 and then 3. So we're going to go up 2 and over 3. There you go. All right. Next thing, let's do this one more time. You know, I should mention real quickly, I forgot about this. I don't know if I mentioned up here, but there's two other terms that are not actually included in the instructions here. One is called a transverse axis, and one is called a conjugate axis. Okay? A transverse axis is the name of the axis. Instead of us saying major and minor, because major implies that's the longest, and it's not. If you look at these, sometimes the one that connects the vertices is actually shorter, but the transverse is the one that connects your vertices. So like in this one, this would be the transverse. Think about trans to go from one thing to another. And then in this one, this would be the transverse axis. Okay. And then the conjugate is obviously the other one. So like the conjugate, when we're talking about this, would be like from here to here and from here to here. Okay. I failed to mention that earlier. Sorry, I'm just mentioning it right now in case you run into it. All right, last question here. We're going to look at this. We got 4y squared. Let's put the y together, put the x's together, keep the constant on the right. We're going to go ahead and factor out a 4. We're going to factor out a -21, and we still have the -99. Complete the square. Half of 6 is 3. Squared is 9. Half of 2 squared is 1, which is, well, half of 2 is 1. Squared is 1. To balance this, you have to think about what we added. I added in a 4 times 9, which is 36. So I do the same thing on the right. I added in a -1 times 1, which is a -21. So I do the same thing on the right. Right as a quantity squared. So we have 4 times the quantity y plus 3 squared and -21 times the quantity x plus 1 squared. Now we end up with a -84 on the right side. Doesn't matter. Just because we have a negative doesn't change the process. Because of the fact that I have a negative on the right side right here, okay, we're going to divide everything by a -84. Now what's going to happen is, because this is going to yield a negative, this whole thing should now end up over on the right side, and because this portion will yield a positive, they should swap places and this should end up over on the left side. So when we look at this, you'll see that that's exactly what we do here, is that we now put the, well, I just simplified it first. And then again, because we have a negative there, what happens is that this negative should be moved over to the right side. And so I rearrange it. Now you can see this is going to open in the x direction. All right. Let's go ahead and generate this graph. I'm not going to do real detail. I'm just going to map it out here for you. We're going to have 2 and root 21, just pulling the value straight down here. The center for this is at -1, -3. We're going to go 2 in the x direction. Those are my vertices because that's what comes first. It tells us we have to go in the right and left direction. So those coordinates there are at 1, -3, and -3, -3. Okay. My center, I forgot to write down, sorry, is -1, -3. My co-vertices, we're going to go up and down, root 21. Root 21 is again between root 25 and root 16. So we know that this is 4, this is 5. So we're going to go a little bit between 4 and 5. So I'm going to go 1, 2, 3, 4, and then extra. 1, 2, 3, 4, and then extra. We're going to go ahead and make our little dotted box. Whoops. Make our dotted box around here. We're going to do our asymptotes going diagonally through these. We're going to go ahead and make our curves going in the x direction, following our asymptotes. For the co-vertices, we said from my center, which was at -1, we're going to go -3 plus or minus root 21. Okay, because we're going up and down root 21 for each direction on that. For the focus, we've got a squared plus b squared is equal to c squared. So we're going to have 4 plus 21 is equal to c squared, which means that c is going to equal 5. So for my center, we're going to go to the right 5 and left 5 because we need them to be inside of my curves here. And so we're going to be left 5 and right 5, which means we'll be at -1 plus or minus 5, comma, -3. So that tells us that we're going to be at -6, -3, and 4, -3. Okay. For those asymptotes, we are going to pluck it straight from our equation. So we got the y plus 3, and we've got the x plus 1. And for the slopes of this, we're going to be using point slope, right? We're going to look at this. We're going to go, well, I'm going to go up root 21, and then I'm going to go to the right 2. So up root 21 and then right 2. Root 21 and then right 2. There you go. That's it. That's it in a nutshell. The only thing that we could actually possibly change here is I might give you something like the length of the transverse axis or the length of the conjugate axis. And we should recognize that if I gave you the length of the transverse axis here, which in this case is 4, then I can just pull a little information from it saying, well, then if that's 4, then I know that this portion is just equal to 2. That's my radius in the x direction is equal to 2. And so then I can go ahead and put a 4 here because 2 squared. And you can work around in different directions. Like maybe I'll give you the length of the transverse axis and I'll give you the focus. Well, you would put that information in here and work backwards to find the A, the B, and the C's. Okay. These problems down here are just review. So you're welcome to try them if you like. But for a parabola, you need to make one change on the notes here. It says it opens to the right. It's not possible to do that. It was a typo. It was supposed to be to the left. So if the vertex is at 3, 2, and it opens to the left, it's going to pass through the point -1, 3. We go ahead and use our equation because it's opening to the left. It's going to be y minus k equals, and then this should be like a -4p right here, x minus h. Okay, we'll go ahead and put in and solve for all of our values that are given to us here. It's going to end up being a negative, but you'll see why in a second here. I put in the h and the k, which is our 3 and 2. I'm going to put in the coordinate which is given, which is our x and y in this. This is my x and this is my y. We're going to go ahead and simplify those and solve. We get 1 squared on the left side equals 4p times -4 on the right. And that means that we have 1 times 4p, or I'm sorry, 1 equals 4p times -4. If we divide by -4, we get -1/4 is my 4p value. So if I take that 4p value and I replace it with a -1/4, my equation looks like this at the end. And that's it. That's what we were just asked. What's the equation? This one right here, it's a big mistake. It's missing covertices. There's no way to actually determine this. You have an infinite number of options you can actually do for this. But we're just going to skip it for the sake of the problem. And then for the last one, the hyperbola that's on here, this is one where you're actually given the focus and the covertices this time. So you'd have to work backwards to figure out what are the actual focuses. I'm sorry, what are the vertices themselves. Okay. So if we work backwards from here, first thing we know is the center is at -2, 3. Now, in order to do this, because I'm given 2 sets of points, you can find the midpoint. So if you remember, to do the midpoint, if you have like -2, 10 and -2, -4, I can add the x's together, we get -2. I can add the y's together, we're going to get 6. And if I divide those by 2, we're going to end up with a -1, 3. Oops. Wait. Nope, I added it wrong. Sorry. It's a -4. Good Lord. My brain is fried already. You can tell. And then we got -2, 3 for the center. So that's where that center came from. Okay. Using that information and the other stuff that's provided, we know that a squared plus b squared is equal to c squared. We know that the distance between my center and my covertices here is equal to 4. You can see that just by mapping out or doing the distance formula. So that's where we get the 16 from. We can see that the distance from the center to the focus is equal to 7. So that means that my C value is going to equal 7. So that makes this 49. That tells you then that your A value is going to equal root 33. So A squared is equal to just 33. So if we put all that information together, we know that the graph opens in the up and down direction, right? That's obviously because of the fact that the focus are in the up and down direction. That tells us that the y comes first. And so if we put our center in there, we get y minus 3 squared and x plus 2 squared. The radius in the x direction is equal to 4 squared, and the radius in the y direction is equal to square root of 33 squared, which is just 33. Okay? That's it. I know it's a lot, but it's all a bunch of little details that you just have to gradually work your way through. I believe in you guys. You've got this. But if you have any questions, please don't hesitate to reach out and ask. Otherwise, you guys take care and be safe. Don't forget to like and subscribe, and have a wonderful day as always.